Thank you very much. Well, I'm going to talk about a use case where we used FME together with a client in a decommissioning project of a nuclear power plant. So first starting here, the first slide here, when I started using FME, I think it was 15 years ago, I never thought of it as a tool to create stunning graphics, but what we see here is actually a 3D PDF in this area produced by FME, and also the smaller pictures here are from the data inspector. So this is sort of an aerial view of the power plant, and the small little pictures here are displaying results of the sampling radioactivity in there. So I also want to give some quick credits here, especially to some brilliant people at the nuclear power plant, very innovative and brilliant engineers, and as you might notice, all have the same name to begin with. It's Lars. So I think being innovating means you can have the name Lars there. And also, of course, to my co-workers at Sweco. I don't have a lot of corporate information, but it can be good to know that in Sweco we do have more people employed than just FME nerds. So we do have people who actually were around constructing the power plant, and they really know the nuclear business and other utility sectors there. So we're not just a bunch of FME nerds running around in a nuclear power plant. That can be safe to know that. So just some quick information about the background here. You can see the blue dot. That's where I'm currently now. I guess you guys are over on that side there. So Barseback power plant is situated not far from here. It's about 20 kilometers from where I'm sitting right now, and it was constructed in the beginning of the 70s. But in 1980, we had a referendum in Sweden where people voted and decided that we should quit making new nuclear power plants and we should stop the existing ones. And that should be done, I think the referendum said that should be done by 2010 or something like that. But so far, the only one that actually have been stopped and taken out of production is this plant, Barseback power plant. So it was completely taken out of production in 2005, I think. So it's been in service mode since then. So that's the background. And it is in a decommissioning phase now. So that is there is a project that we've gone for a very long time because it's very complex to figure out how to dismantle it and what the place should be used for after dismantling. So in decommissioning, it's very important to have an initial radiological survey of the area, of the plant. And that is because it's very important to estimate how much contaminated material there is in this plant, because it's very important to handle contaminated material. Just working with it is more complex, but also it's supposed to be stored somewhere in the world later on, and storing contaminated material is of course very expensive. So getting a good estimate of that situation is very important. And the theory here when we began this project was that the 3D model could help with that. So help with planning, acquisition, and visualization of sampling data was one idea. And of course, if you have a good 3D model, you can help with the logistics in the actual dismantling process and in the planning of the process. And we also do believe that seeing is good for checking quality. And if you can see data in 3D, it adds another dimension to quality assurance. So as I mentioned, the plant was constructed in the early 70s, and basically it was done on drawings, and thousands of drawings. So that's actually the originating documentation. And of course, that documentation at some stage was scanned into a computer as rasters. And there was a big project that converted them to AutoCAD files. So that was the source that we could work with to try to create some 3D out of this. But it's flat 2D CAD files in that case. But I must say it's very accurate information they have at this plant. All documentation is really very accurate and in good shape, even if one can think of it's in an older way of storing it, because of course if you build a new nuclear power plant, you're probably using BIM or something more advanced in 3D. But this was constructed in the 70s and was shut down in 2005. Just to show that the rasters have been vectorized, I symbolize that with a little square there. Now, what we did and how we used FME was that we started working with these CAD drawings in a similar way that Dale just showed, that we set up a transformation pipe where we added control points to existing CAD files. So defining each floor with a control point, but both in X, Y, and Z. So we get both the real coordinates in 2D and in 3D for each floor. And I should mention this while I remember it, the power plant has its own local coordinate system. So what we do in the transformation process is that we cut out each floor, because there are several floors there can be several floors in one drawing. So we cut out that and we do the extrusion pretty much like Dale showed before, and we stack the floors on top of each other. But during this process, we also try to maintain some sort of intelligence. We try to keep intelligence in the model, and we see there that we have connected an Excel file with data. And an important thing to keep in this are the room numbers, which is very important, I think, in general in nuclear power plants, because all documentation is often connected to the room numbers. And by doing this, we can connect and visualize results. In this case, it's mostly about results from the radiological survey. Now, if we look down to the right here, here's what the more simple extrusion looks like. It's not that super fancy for each room, but you get the height and the width of the walls, and you also get a simple door opening in that. But we do some more fancy. Yeah.
On this one, I noticed you have a label there, the V03. Does that is that picked out, or do you do something more interesting with that?
Yeah. That's the room number or the room ID. And we actually use that. If you look at the picture up to the left, you see an elevator shaft going through the floors, and that's one solid object. And that means that that room have the same room ID, even if it occurs originally from different drawings.
Okay.
So what we do is that we try to maintain those as one object, even if they cross several floors. And that's also what we can see, that we have punched holes in the floors and ceilings in the model. So it's a bit more complicated than just doing the extrusion. We get holes in the building. Now, in this process, we use FME, and the great power is that I think that we can use so many different sources and do a lot of stuff with it at the same time. We have a digital elevation model for the entire plant, which is very high detail. We had the CAD drawings that I just showed. We went to land use information. We had different kind of map data, of course, different kind of tabular data. And all this is entered into FME, where we we mash it together. That's a good word, I think. And a good thing with this is what we can decide what we would like to output. We do output a lot of 3D PDF, but we can also write three-dimensional AutoCAD files, and of course 2D if that's wanted, even if we stored this in 3D. Now, this is another screenshot from the actual model. As I see there, you can see there is a room. We are marked there with a room ID, and this is very important to be able to search for a room and display it like this. And we have another thing that is.
So Ulf, that's searching. Yeah. The searching, Ulf, is that just part of Acrobat Reader that you did that in that previous one?
Yeah, we can say that. In this case, we just have clicked with in Acrobat Reader, but the search capability is very important when we connect data, and we often do that with FME. Say you have an Excel spreadsheet with data for a room, then we can connect that and output a 3D model for that.
So then you see all the properties of that room when you select it.
That's true.
Okay.
In this case, we also make cutouts, or I don't really know the best word for that, but that is that we show a part of the building together with the ground in this case, and that means that we can, first of all, it gets a bit easier for the user to find a specific room, see just the surrounding areas, because it can be hard to navigate in a complete 3D model. And in those cutouts, we can also turn on, say, the floors above the specific room I look at, but we can also turn on what's below the ground. So this is also from a 3D PDF, but we're looking at part of a building from below. And I think I'm going to try to show, let's see, I'll take up a 3D PDF here. So here we see an aerial of the power plant like this, but I'm actually running live. I don't know if it's streaming good.
Yeah, we can see it, Ulf. One thing I wanted to ask you, didn't you used to live right over there on the far left of this?
Temporarily, we rented a house that was very close to this one. So when we woke up in the morning and have a breakfast, we could look straight to Unit 1 of this one here.
How do you think you got his powers? That's how you got your powers, I guess. That's true.
That's excellent. But the thing here is, and what's very good here is that we can see, if we actually peek in here, we can see that we have colored dots in here, and these are results from the radiological survey that are fed into the model. So we can see results from that both from the inside, and we can also look at results on the outside. And that's one thing we can do with FME, to combine the data sources and display it like this. So I'll try to flip this one around.
So Ulf, those results, do they come in, must be from like spreadsheets or databases or something?
Oh, it's a bit more complicated like that, just saying that. But we can say at one point there are in Excel, just before we feed them into the model. So let's say like that. And we can go to an area here where we have colored, depending on the result. Here's different colors. Well, it looks a bit dramatic, but it really is not that very high radiation levels or so in general, as I understand it. So this is a fairly complex 3D PDF, and it really works pretty well with those. They can handle a pretty big amount of data. Let's see if I can go back to the slide here. Yeah, and another way here, when they do the actual sampling, collecting data, they do that both indoors and outdoors. And we use FME here too, in a way, because in the model we define a grid for each room. You can see the numbers in here. So that room we highlighted there, it also has a grid. And that means that they can make printouts of this 3D model into 2D. This is actually a PDF created from that model, and you can make notes on that, where you have taken samples in the room. And there are a lot of rooms. I think there are over 2,000 rooms at a site like that, so it's almost like a small town. So this is where they can mark where they have taken the samples. And what we do with those samples, if you look at that printout here, we have tagged them with a QR code, a custom transformer we made for that tags the paper with where it is in 3D, and also the name of it. So we can bring that back into the model. When we receive those prints with notes on them, we run them through FME with something we call a QR detector that detects the QR codes and extract the true coordinates. So we can then position the printout, but also by some image analysis, the actual dots that have been marked, and that's the way how we collect the position of the different samples. And this is an example.
This is quite an amazing. It's quite an amazing integration of a number of technologies that ultimately end up being a very low-tech way for data collection, but very accurate.
Yeah, and the reason is, of course, that there are technologies for positioning indoors, of course, but it's very complex to do that in a nuclear power plant where you have, say, a meter thick concrete walls and getting stuff to work there. I'm certain there are technologies that could be used, but it's a fairly complex process to get that running. So this was...
To be very, very clear, Ulf, that QR stuff, that's custom transformer that you guys have written. It's not part of FME, but the gods in Asgard have figured that out, and so I guess that's something that you've extended FME with.
Yeah, that's true. It's fairly easy to make a transformer that writes QR code, but it's a bit more complex to find them in a raster and use it like that. So that's when you need some form of custom format there, a custom plugin. So this is a view where we have collected those results and displays it through 3D model. Now, the outdoors, where you collect data outdoors, is in a similar process. It's also based on a tiling scheme out there, where you perform the radiological survey, and like I say, it's a bit more complex than just going around with a Geiger meter. It's really very impressive how they do this, and that's because you have to figure out how to filter out background radiation and stuff like that. But basically, those points are collected in a similar way, we can say, but and those are also fed into the model. So what we can display is both indoor results and outdoor results at the same time, and that is something very powerful when you analyze data, because you can see if you have relationships between the inside of the buildings and the outsides. So I'll try to run a little movie here at the end. I'll see if I can get that working. Okay, and just some more slides on the intelligent papers, try to explain that process again. As you see, when we scan those backs, the actual prints are positioned in 3D where they are, and you can see those cylinders here. This is where we position the samples, and this is also done with the FME, with the raster capabilities and some image analysis to actually filter those out. And here is a view where we can see all of these points that have been collected. Let's see, I will try to run a movie here and hope it streams well over the internet. Showing here. Here's one of the workbenches. As you can see, it was a bit more complex than the one that Dale showed, but it's very much the same techniques. And here are some example that we also output more regular maps from this model, and how we can tilt things around. And as you see, we have the results from inside of the building. And I'll stop this one here. A good thing about this is that as we get all the information into the same coordinate system, we can also include 3D models that already exist. In the plant, they have very detailed models of certain areas, for instance, the reactor. So this view here is created by using FME to read a very high detail AutoCAD DWG file and combine that with the extruded walls, so we can see that it all fits together. And you can see it's a very detailed model here. And how I'll just end the presentation here with showing how it looks when we have positioned those scanned papers, that we can see that they really are in the 3D space. And here we extract the actual surveyed points into the building there. So yeah, here we see it's. I think it's more than 3,000 points that have been collected, and we have results of radioactivity in all those points. I think it was pretty much all I had to show, but Dale?
Okay, so we had a couple questions before we move on. One person has asked, for this job, did you rely on the original plans as accurate, or did you conduct an as-built survey to verify them? If so, did you use laser scanning to do it or not?
Oh, that's a good question. We're actually working with it now with the accuracy, and what we are using are benchmarks that already exists in the power plant. There are small copper plates all over the plant that were put in there while they constructed it, where we have the actual points. So we're using those to control the accuracy of the model. Now this is a first initial survey, so we don't aim at having the same detail as a laser scan for each room, but we can probably use this model to decide which rooms should be considered for laser scanning, because if you can exclude entire areas of the plants with less contamination, we probably don't need a laser scan for that area. So.
Right, very good. And the other person asked an interesting question. It's more to do with our 3D PDF. He said, in the Plan 3D model, it seems like he saw lines in 3D. Can you explain what they were? And I'm not sure if he means, can we output actual line objects in 3D, or if it was just the wireframe. But in your experience, Ulf, do you always have to extrude things, or can you output actual line objects to 3D PDF?
I'm not really sure. The way we would do it, if we were to write a line, we would probably say enter, and we needed to extrude it. We would probably just enter a small buffer around it and extrude it. So we haven't really thought of it as a problem like that.
I guess the other interpretation of the question is that maybe some of the lines that we saw might have been roads and other kinds of sort of physical features. I don't know, precisely what the person was asking, but that's still, useful to know. I think I recall we can't output an actual line object to 3D PDF. Would you agree with that, Kevin?
I think there is some restrictions there in the current FME 2012.
Yes.
Yeah.
So anyway, thanks very, very, very much, Ulf, for that, and we'll just continue on, and Ulf will be available to answer some more questions in a few minutes when we wrap up.